So I don't know what's happening tonight. All right, I am now recording again. All right, so here we go. I'm going to share my screen, see if the second attempt actually works. All right. Okay, so you should see a PowerPoint being presented to you, do you?
Yes.
Excellent. All right, so when I first took physics in college, I was fortunate enough to have the chair of the department teach me. And one of the things that the chair did is he wrote up this little diagram. And that what this diagram shows you is where physics resides with respect to the other sciences. All right, and so the universe, you know, we're trying to understand the universe, and mathematics is the language of the universe. Galileo once said that God wrote the universe in the language of mathematics, and so physics is the direct interface with the universe. So you see, physics is really the base science, the science that interfaces directly with the mathematical laws of the universe. And chemistry really derives from physics. And we understand this more and more as we progress throughout the 20th century and beyond, is that really chemistry is the application really of quantum mechanics and thermodynamics, both of which are in part of the physics curriculum. So, and then from chemistry, you derive higher sciences like biology and geology. All right, and so a lot of you live up in the upper area, like in this class in biology, for instance. Some of you are in chemistry, but what you have to understand, though, in the most basic way, is how does physics relate to your particular science? And for instance, whatever it is that you're going to do, maybe you're going to be a medical doctor or whatever it is that that you're going to whatever science that you're going to partake. There will be physics applications and devices and machines, and really the idea is you want to understand the principles behind these and how things work. And so there's a number of different aspects you're going to learn about science, not just physics, but also how to be a scientist. I mean, if you're in this class, you're here to perform, to understand how to become a scientist, and all scientists really behave the same way. The truth is based upon experiment and theory. All right, and so when I see theory, this kind of gets into the second slide. There are many terms in science that are misused in the vernacular. One of these terms is theory. Theory is, we hear about, conspiracy theories and all this other stuff. I mean, that's not a theory. A theory is a mathematical framework that precisely predicts a wide class of physical phenomena and is fundamentally based on a set of physical laws or principles. All right, that is what a theory is. We will study two theories in this class: the theory of mechanics and the theory of thermophysics. Now, when I talk about a fundamental set of physical laws, what is a physical law? Well, as I say here, a physical law is the behavior of the universe that is always true, but does not have a more primary cause. It is a primary cause. There are certain fundamental behaviors in the universe that we do not know why they are true, but they are. They don't have to be true, but they are true. And if you kind of liken the study of physics to, say, geometry is like the first proof-oriented math class for most of you, if not all of you. In geometry, even though it's all fundamentally based on proofs and theorems, there are two fundamental concepts upon which all of Euclidean geometry relies that you cannot prove. One is a point and one is a line. You cannot prove a point, you cannot prove a line. All the rest of geometry essentially burgeons from those two concepts. All right, and so in the same manner, physics, all the physical theories are fundamentally based on certain laws. And so, for instance, I talked about we have two different theories that we're going to cover in this class. One of them is called mechanics. Mechanics will cover the first 11 chapters. And mechanics discusses how bodies move. It's a study of bodies in motion. Now, mechanics is very successful, but if fundamentally relies on just 4 laws: Newton's 3 laws of motion and the law of conservation of energy. Now, I say energy, at this point, we did not even know what energy is. Many people, believe, and then they walk into this class, or many people who don't even take science classes believe that they understand what energy is. But if you ask yourself, closely, what is energy? I would say that most, if not all, people really do not know what energy is, and including some practicing scientists. Okay, we'll discuss what energy is in the most fundamental sense in this class. But these 4 laws, all of mechanics, objects in motion, whether in all 3 different modes of motion, translation, where an object moves as if it is a point particle, rotation, where it rotates about an axis, or oscillation, or a fancy word for vibration, where different parts of the body move with respect to other parts of the body, oftentimes in the undulating or sinusoidal or vibratory motion. Those are the ways that mechanics, those are the fundamental motions of mechanics, and yet all of them are based on these 4 fundamental principles. And not only that, all 3 fundamental states of matter: solid, liquid, and gas. Liquids and gases are together called fluids. We studied fluid mechanics in chapter 11. All of objects of motion in the 3 modes of motion and the 3 states of matter are all fundamental applications of just 4 principles. Now, we don't know why these laws of physics exist. If you were to ask a bunch of why questions, like kind of like an 8-year-old talking to you, and you're to, in this person asks you, okay, why is that? Well, it's because of this. Why is that? Because of this. Eventually, you will get to a law of physics. If the question is why, if the answer to one of the questions finally is, say, Newton's second law, well, that's because of Newton's second law. And if the next question is, why is Newton's second law? The answer to that is nobody knows. That's where science ends. So you might say, if you're a religious person, you might say, well, God made it so. But that's where science is. As far as what a scientist is concerned with, this is the base. This is the basis of the whole theory. Now, that's the first 11 chapters of this book. And I'll talk about the book, that we're going to study out of it. The book in this class, the first 11 chapters will be mechanics. Then we move on to the theory of thermophysics. That's the study of energy transformation. There's that word energy again. And we also talk about certain concepts called work, that's a form of energy, heat, another form of energy, and temperature. We'll find out that temperature is also related to energy as well. It is based on the 4 laws of thermodynamics: the 0th, 1st, 2nd, and 3rd. Okay, again, in a wide range of phenomena, we're going to cover that in chapters 12 through 15. All of it is applications of just 4 laws. And then we end the class on the concept of waves. If you were to ask the question, well, where do waves lie? Well, the answer is waves are actually, we initially defined them as a disturbance that propagates. But in reality, waves actually are much more fundamental than that. They actually are a statement of existence. So waves, everything in the universe is both a particle and a wave. That may make no sense whatsoever. That requires quantum mechanics. We're not really going to talk about that here, but the reality is waves are across all the theories. So you have mechanical waves, like waves on a string, water waves, acoustical waves. You have electromagnetic waves. So waves pretty much they belong everywhere. All right, and so that's how we're going to end this class. Now, understand that this is college physics and not university physics. So the question is, what's the difference? Well, university physics, the mathematics is correct. The true mathematics is actually followed in university physics. That's the calculus-based mathematics. So university physics is calculus-based. This class is not. The prerequisites for this class are algebra, college algebra, and trigonometry, or pre-calculus. Pre-calculus contains algebra, trigonometry, and more. So those are the prerequisites of this class. I will teach you, and I will show you what the certain notions of calculus are, but I'm not going to actually I'm not going to hold you accountable for understanding calculus. I really want you to know that there is stuff that you're missing, and where are we making approximations to skirt using calculus. But to do this class correctly, you would use calculus. Now, why do some people take university physics and some people take college physics? It's really fundamentally based on your major. And so if you are, I can tell you this much, if you're a physics major, a math major, computer science, or any form of engineering, mechanical, electrical, civil, chemical, you don't belong here. You belong in university physics. If you are some form of bioscience, so it could be biology, pre-med, pre-vet, pre-dental, pre-optometry, so on and so forth, or pharmaceutical, then you do belong here. Now, who makes these decisions? There's always a governing body in any kind of discipline. And these people will make the decisions on what goes into the curriculum. Let's say you're going to medical school. Well, people will say, well, what do we expect our students to cover in pre-med? What are they going to cover in medical school? And so again, these decisions are made, and I've been around the block long enough to realize that what the governing bodies actually decide are very accurate. They're very wise. They know what they're doing. They've been around the block. They're in those positions for a reason. And so, and sometimes it's your school. Some pharmacy schools say you just need physics 1. Some say you need physics 1 and physics 2. So again, know who your advisor is. If you don't know your advisor, I can tell you who your advisor is at TCC, or also know what your goal is. Where is it you're trying to go? Okay, that determines what you need to take. So again, every semester, I always have somebody sign in here initially who really belongs in university physics, and yet they've started in college physics. Sometimes they wait until they realize this when they're 2 or 3 weeks into the class. At that point, I'm like, well, you might as well just finish the class at this point and then decide what we're going to do after that. But again, I'm hearkening on this because this happens a lot. I've been teaching physics here since 2017, and pretty much every semester I have one student who is misplaced. So make sure that student isn't you. All right. Okay. What am I going to do now? I've talked about the high level of physics. So I'm gonna kind of talk a little bit about myself for a second, who your professor is. Then I'm gonna kind of walk through Blackboard. If you're not familiar with Blackboard, some of you may have had classes here before, some of you haven't. So again, I teach the common denominator. So some of you might be bored when I go through Blackboard, but there's a lot of very important documents on Blackboard I want to talk about. And then I eventually want to go through the syllabus. And then I want to take attendance. And then that's really the long and short of this class. So, so as a scientist, you should always challenge everything. Don't believe anything until you prove it. And so when someone tells you something, it has to be evidence-based. So I go and I tell you, hey, I'm your physics instructor. I'm your physics professor. You should ask me, who are you? Who are you to teach me? What are your credentials? Right? And so I'll say a little bit about myself. So again, I'm Mark O'Callaghan, PhD, or Dr. Mark O'Callaghan. I have 5 college degrees. I have a bachelor's in physics, bachelor's in math, bachelor's in mechanical engineering, master's physics, PhD physics. I have multiple papers published in physics journals. My major areas of research are quantum mechanics and statistical mechanics. And so I have taught here at TCC since 2017. And so I have generally students are happy with me as a professor. I have people coming from all over DFW to take the class. And so, and honestly, one of the things that was put on Rate Your Professor I really liked was somebody wrote that he teaches you as if you're his colleague. I look at, and I see my students as like colleagues. I respect all my students. I realize they're here for a purpose. They want to be successful. They want to be scientists, and I treat them as such. I treat my students with respect. I want respect throughout for everybody in this environment. I want you to feel free to talk to me. I want you to feel free to communicate with me in every way. And so again, I got my master's degree and my PhD at night, and I realized here you are at night, and here you are. Many of you have jobs, maybe significant others. You have all a bunch of things going on in your life, maybe children, and you are making a sacrifice to be in school. And I understand that. I made that sacrifice as well, so I respect that. And so again, the idea here is I give you an avenue to succeed in the class in many different ways, but you're going to have to do your part to do the work. I want people to succeed. I want my students to be the ones that get high scores on the MCAT and do really well on all the other exams and do really well on the other courses. I want them to be the ones that are prepared. So I root for you. I do everything in my power to try to have you be successful. All right, and that's the approach that I have. So I don't. Physics may be a GPA buster for and if you take it from a lot of professors. I certainly don't want that to be for me. I want you to actually look upon physics. Well, I really enjoyed that class. I really learned something in that class, and I got an A or I got a B. I did well in the class as well. So again, I want that to be the experience, not like, oh, what a horribly dreadful class that was. I never want to take another physics class the rest of my life. That's the experience I don't want you to have. All right, and so again, this is I want you to treat this class like you would any other class, or so that's the approach that I take to it. All right, so that's me. I mean, I'm originally from Washington State, and then I lived most of my life in Washington State or California. I came here to Texas in 2007. I live in South Lake. I have a couple of children. I'm married, and I work for defense industry. And so I worked for BAE Systems. I worked on the Global Hawk program when nobody really had unmanned planes. I did a lot of the mathematical algorithms to to let the plane have the planes make decisions on its own. So we now have these drones and stuff like that now, but it all started as a dream, and I was part of that whole process. When I worked at Lockheed Martin, I worked on the Skunk Works. That's all the programs that nobody can talk about. Let's see here. I worked in the Joint Strike Fighter, and then I joined Raytheon. I got my PhD in 2016. Joined Raytheon the same year, and I pretty much do research there. So I'm a level 6. I'm like a equivalent of a full bird colonel, if you will, at Raytheon. So I'm one step below executive. Maybe one day I'll be there, but anyway, at this point, so I have industry. I come here with industry experience, academic experience, and a passion to teach. So that's who I am. All right. So let me now show you Blackboard. All right, now this class is kind of the last of a lot of things. First of all, it's the last set of classes in the pandemic. This is the last class that's going to be taught virtually. In the fall, I will teach this class face to face. And so this is the last set of classes. Hopefully, some other virus doesn't come around and bite us, but there's the last class in this pandemic, and we're going to go back to some form of normalcy after this, right? And so and also this is, I believe, the last semester or last term where we're going to have Blackboard. We're all going to go to what's it called, Canvas after this. I have to kind of make sure my kids are on Canvas, so I kind of know a little bit about it, but I haven't actually paid attention to it yet. So again, that's how we're going to do. So this is the last semester of Blackboard. So anyway, some of you may have been here before and some not. So let me kind of just briefly show you Blackboard. All right. So again, maybe boring for some of you. I apologize, but again, I'm teaching to the common denominator. So let me go, and I have the internet up here. So you should see Tarrant County College website. Again, that's you get there via waj.tccd.edu, and you should see something that looks like this. Now, this is you click on this the Web Advisor link, Web Advisor. Now you'll enter Blackboard differently than me. I'm a faculty member. You're a student. And so in Web Advisor, oops, hang on one second. I guess I logged in a long time ago, so give me a moment. All right, let's try that again. Zoom tends to slow down all of my processes. So I try to bring things up beforehand because I know how slow it is. Zoom, for some reason, is kind of a dog, or a hog, I should say. All right, so here we go. So now we're one page down from the Web Advisor. Now you'd come in there as students. I'm entering a little different way. I'm entering as faculty, but again, it's neither here nor there. And I'm going to go to Portal. And then depending upon what classes you're taking, you should see an entry for this Physics 1401 or college physics class. Again, things are coming up. Sometime between now and Christmas, it'll come up. So again, my computer's usually not this slow. It's just Zoom. All right, so give me a moment. It's coming. All right. Sorry. All right, here we go. Sorry, I'm looking in the wrong spot. All right, so I have summer 2021 Physics 1401. So you'll see something like that. I believe I've never actually been in here as a student before. But you'll click in here, and in Blackboard is going to be everything you need. Now, you can make Blackboard as complicated as you want. I mean, I've been the lab professor for Dr. Edmonds before, and he sets up little folders, and he has a very beautiful arrangement he makes. I'm more of a slob, I guess. I just throw everything in lessons. So every single thing you possibly want to know is inside of lessons. All right. So the question is, what's inside of lessons? Well, I'm going to cover all of these in turn. You have the lesson plan. The lesson plan is the map of the class, and I'll talk about that. That tells you what we are doing at every juncture of this class. There is the College Physics 1 homework problems. We're going to do 17 chapters in this class. This document gives you every single problem that's assigned for every chapter. And I'll talk about that document as well. All right, Uniconversions. These next two are just basically for your assistant, your aid. Uniconversions really helps you convert between one set of units to another. There's physics, any kind of thing you measure in physics has a particular unit, like the distance might be in meters or kilometers or centimeters. How do you convert from one to the other, or miles or feet? It could be weight, could be in newtons, could be in pounds. How do you convert from one to the other? That's what this is. Significant figures, we'll talk a little bit about that in the first lab. Significant figures really talks about how many decimals can you express in an answer. When you measure something, if you're going to go and put 3 or 4 decimal places or numbers after decimal places, that means people understand that as you're able to measure with this level of precision. If you cannot know something with a level of precision, then you need to write down a smaller number of decimal places. I mean, so again, significant figures really is a statement of precision. How well do you know something? Again, so this helps you there. We'll talk about that a little bit more in a moment. We're going to have, normally when we meet face-to-face, we have labs that are ordinary labs. Class is called physics, means it's physical. But again, with this pandemic, we've had to resort to using physics simulations. And so there's the labs, or simulation labs, are from the University of Colorado. They're called the PHET simulation labs. With the exception of the data analysis lab and the vectors lab, all the other labs are going to be simulations. All right, so the very first lab we're going to have is a data analysis lab. I'll talk about that a little bit more, but all the labs that you could possibly possibly do in this class are all located right here. All right, and then you'll see links to YouTube videos. I have made YouTube videos for every single lecture. I've pre-recorded all the lectures in this class in a very detailed way. So all the lectures are there for you. And again, all you have to do is click on a link and start a YouTube video for every single chapter. Some of them I had to do a second video to kind of, but generally speaking, they're, all those YouTube videos are there in order in a very organized way. And in fact, I have also pre-recorded sessions for all of the labs. And I pretty much walk you through all the labs. All right, and so again, these are on YouTube. All you have to do is go to Blackboard and click on the corresponding link. At the very bottom of what's in lessons is going to be the course syllabus, and that's what I'm going to walk through a lot tonight. It's the course syllabus. All right, and so all of that's there for you. What else am I going to put in there? Well, I'm going to put any kind of homework solutions. Once you turn a homework in and it's already been turned in and it's been due and a due date's passed, I will put the homework solutions out there for you to peruse. And so and I'll talk about how to submit homework and all this other good stuff. So again, that's all of that is in on Blackboard. All right, so I'm going to stop sharing. And I'm going to go and talk about the various documents that are in there. So as I cover things, I'm going to kind of kill stuff. So all right, so I can have fewer processes running on my computer. All right, so the next thing I want to talk about are some of the documents. So let's start off with let's talk about the homeworks. So let me share that. So again, I've already pre-opened these so that I spend less time waiting. All right, share. So I'm going to kind of talk about some of the documents I just pointed at. Let's actually talk about them now. Okay, what you should now see is the College Physics 1 problems. Now, Cutnell and Johnson is our book. I'll talk about that in a moment. I mean, I wrote the book down. It's Cutnell and Johnson 11th edition. I'll actually show you I'll hold the book up to my camera in a little bit. But in Cutnell and Johnson, what we're going to cover, like I say, is the first 17 chapters. Now, I want to point out something. I have a nomenclature for this class to be able to eliminate any ambiguity. Now, for instance, let's say you see the first problem in chapter 1, you see 1.4. Well, you're not going to see a 1.4 in the book. What the nomenclature means is, I've written on the top here, is it's the chapter number dot problem number. What that really means, when you see 1.4, that really means chapter 1, problem 4. So you see you're not going to see 1.4 in the book. In the book, you'll go to chapter 1, you'll see problem 4. Not 1.4. What I want you to do, I want you to write 1.4. That way I know that it is really uniquely problem 4 out of chapter 1. So when you go to chapter 2, and then the second line, in the problem set, you'll see 2.4, 2.9. Again, those are problem 4 out of chapter 2, problem 9 out of chapter 2. So again, and you see as you go along, all of there's 17 chapters altogether. So if problem 21 in chapter 17, well, that's 17.21. Please use this nomenclature when you do your problems. Okay. So again, all of the problems that I will ever assign in this class are located right here. Okay, there will be, I mean, that is it. So all right, so that's the problem set. Let me close that down. Now, when do you know when to do what problems, when to study what chapters? So give me a second here. I'm just gonna kill things as I go along. All right, so this is where we go to the lesson plan. I'm going to bring up the lesson plan in front of you now. Again, this is not a fun lecture. This is just kind of covering what things are and where things are. All right, lesson plan. You should see that in front of you now. Now, if we're meeting face to face, we would meet Monday, Tuesday, Wednesday, Thursday, starting at 6:30. And we would do lecture only on Mondays and Wednesdays, and lab only on Tuesdays and Thursdays. So if you were to meet face to face, we would all on Mondays or Wednesdays, we would all go and meet in the lecture hall, and we would go and just do a lecture. We're done with the lecture, we go home. On Tuesdays and Thursdays, you would just meet in the lab, and we would just do the lab, or whatever lab it would be for that. So what I've done is I've tried to adhere to this kind of a schedule. And so what this really tells you is, what are we covering in a particular week? Now, it was kind of easy the first week. We didn't have a Monday. That was Memorial Day. So this week is only Tuesday, Wednesday, Thursday. I'm not going to do anything for Tuesday, because Tuesday is just, hey, how are you doing? We're just getting started. So for this week, we're just going to cover chapter 1 and the data analysis lab. Next week, generally, you're going to cover 2 chapters or 2 labs. All right. And so again, this class goes very fast. And that's just because, again, you're putting 16 weeks worth of stuff in a period of just 10 weeks. And so what you do in a given week, you figure, okay, what's today? Well, today's June 1st. What week am I in? Well, okay, I'm on the June 1st through the 3rd. Well, what are we covering this week? Oh, chapter 1, Introduction to Mathematics and Mathematical Concepts and Data Analysis Lab. Okay. Well, that means that to you as a student, you know that you're going to need to view the chapter 1 video, and you're going to need to view the Data Analysis Lab video, and you're going to need to print out the Data Analysis Lab, and you're going to need to, read the chapter 1, do the homework problems. That was fairly easy the first week. I mean, there's only 4 problems for chapter 1. Now, I will warn you, the Data Analysis Lab is fairly difficult. I mean, it's a mathematical review. Now, I try to go over everything in the video, but again, it really is a review of the math that you should bring with you. And it's really math that's very important for you in your laboratory analysis. Now, in this class, this Data Analysis Lab, it's one of those labs you probably want to keep with you for your other classes, because it's the math that you do in the lab. You talk about standard deviations and variances and averages and things like that. This is all stuff, all what you do in this particular data analysis lab. This will apply to your chemistry class, your biology class, anything where you're doing a lab that does measurements. But you don't want to put the data analysis lab off at the last minute. I mean, the thing you really want to do is print it out and start working on it. Okay, now listen carefully. The homework for a given week is due the Wednesday of the following week. Okay, so you look at what's the homework for a given week. What homework is contained in a particular week, and that is due the Wednesday of the following week. And that is due in such a way where you do the problems, you write them out in pencil, make sure it's dark enough that not only can I read it, you should be able to read it. But then put it in a scanner. Scan it, in order. All right. And so when you do a scan, you output a PDF file, and that PDF file you want to attach to an email. Now I'll go over, I have a special email that I created, a Gmail that I created just for turning in homework. So again, I'll talk about that later. But again, you're going to want to send that email to me, to that account, by 11:59 p.m. on Wednesday. So the 4 problems that you see in the chapter 1, you watch the video, you'll work out the problems, and you'll and then again, you're going to want to show your work. I talk about showing your work in the videos. I talk about everything in the videos. But then and I'll show you some examples of what a good scanned document looks like. All right. And so again, I'll show you that in a few minutes, you know. But if you don't have access to a scanner, the other thing you can do is open up a blank MS Word document, totally blank, and then take pictures of your homework with a cell phone, and then place those pictures actual size, right side up, into the Word document. So again, my preference, of course, is the scanner. But if you don't have access to a scanner, then the Word document's the next best choice. And I'll show you an example with a student gave me permission to show her work. I'll show you an example of a good document that you'd want to use, or a good example. You know, don't send me like a little thumbnail or something like that. Do not send me individual photos either. Again, the two methods of turning in stuff in this class, this goes for homework and labs, is either, my preference is the scanned PDF, or the empty Word document where you paste pictures, real, again, actual size, right side up, into the document, and in order. Right side up, actual size, in order. I say this because I've had people turn in stuff upside down. I've had all kinds of different variations of turning in work. So again, homework for a given week is due the Wednesday of the following week. Labs for a given week. Now, you're going to want to generally print out the labs and work in the labs. You're going to want to turn in. I mean, again, I'm going to want to see sample calculations. I'm going to want to see your work. So there'll be some, and sometimes I'll ask you to make a graph or a plot. And again, this will be done in the lab. I'll ask you for that. Those would be additional pages that you'll turn in. But generally speaking, people turn in the lab document itself that they printed out, and then they put additional pages, like extra, you know, maybe extra page or two to show work, maybe a sample calculation of how it is you arrived at your results, your calculations. And also, if I ask you to make a plot or something, that's an additional page as well. So all that's put, you know, turn in as well. And you prepare it like you do your homework, and that's due the Friday of the following week. So again, all homework for a given week is due the Wednesday of the following week. All labs for a given week is due the Friday of the following week. And again, the due times are 11:59 p.m. And again, it's due via email. Okay. So again, how do you know what it is you're going to do? Well, again, you look at this lesson plan. The lesson plan has wrapped up everything you're going to turn in. And in fact, it also tells you when the exams are. Now, the exams are always on a Thursday in this class. Okay, so again, the week where we have exams, we'll have one fewer lab. All right, so they'll actually take the place of a lab. So you'll see our first exam will be at 6:30 p.m., June 17th. You'll sit in front of your camera like you're doing now, and I'll proctor you. And you'll need to take that exam sitting in place in front of your camera, and do the whole thing in front of me, and then prepare your exam like you would your homework. Email that to me, and when I receive your email, then you can leave the session. So again, the exam will appear on Blackboard. You'll open it up, start working on it, and again, I'll talk more about this as the class progresses. And then you're going to want, I'll send you a Zoom link. You're going to want to be in front of your camera. Again, I'm only requiring 5 sessions of attendance this semester. One is today, and the other for the exam days. And there will be 4 exams. So we do have a holiday. 4th of July falls on a Sunday this year, so we end up having off that Monday, July 5th. But again, you'll see how the exams are. So every single thing that's due in this class is all wrapped up in this lesson plan. All right, so this lesson plan is as I said, the map of the class. Okay, any questions so far? All right.
I'm sorry, I have one.
Oh, go ahead.
Taking a while to unlock it. Right now, what if like we have an in-person class during that time for July, not right now?
during
I can probably,
6:30 time
yeah, I have a class that starts at 6 and ends at 9 at TW
on Thursday?
in July. So Monday through Thursday, yes.
All right, well, send me an email about that. Maybe we can try to work something out. Again, there's only one of me and this class goes at 100 miles per hour. So it's really hard for me to make exceptions. I mean, because A is the summer, then B is this virtual. And I'll tell you right now, the virtual is as much of a pain probably for you as it is for me. It's a grading nightmare for me because I got to go and I have 60 emails a week, coming in, and I got to go and process everything. So I'll talk about a little bit about that. But anyways, what's your name? Karen. Okay, I'll send me an email. And I'll talk to you again a little bit when I do the attendance. But again, send me an email, remind me of this. Otherwise, it's going to go on one ear and not the other. So,
Okay, sounds good.
You bet. Any other questions? Okay. I apologize. I didn't dig these assignments. So I'm gonna give you a nice example of nice looking homework. So bear with me a second here. Oh, let's see. Yeah, okay. These people were my spring class. Give me a second here. Okay, I think I got it. No, I'm sorry. I should have done this beforehand. Give me 1 second. I'm just looking up for the students that gave me permission to show their stuff. Yeah, I mean, I want to just kind of give you a nice example of what nice looking homework looks like. Here we go. Okay. Yeah. Okay, so scan documents. Again, this is the most natural kind of document that you'll turn in. It's just and again, this is one of the nicer looking documents this young lady does. But again, you don't have to do it like she does, but to kind of give you an idea. This is work that was done. This is for physics 2, but you notice that all this work is done in order. So now she actually kind of typed some of her stuff out, and then she'd write it out in a very nice detailed way, and she basically would just scan it. So you kind of see all the work is being done in order. It's very, very nicely done. And all she really did is, she just worked this out. Now you can handwrite everything. You don't have to do like what she did and type up the questions. If you so desire to do that, that's perfectly fine. But again, the scan document is the most natural way. And I prefer that you write in a kind of a darker pencil. But again, that's the you just basically put all in order, and you just put it through a scanner and you get a PDF file and send that to me. Now, again, as I said, if you don't have a PDF file, one of the things you could do is open up an empty Word document, and I, this young lady here, Chelsea, did a really good job with this. So I'm bringing up this Word document right now, but this is what you do is bring up the empty Word document and you just take pictures of your cell phone, put them in order, actual size, nice and neat. Make things neat, because help me help you. The neater your homework is, it's easier it is for me to grade you. So give me a moment here. I'm bringing up this Word document. I just want to kind of give you an idea of what to expect. Again, there's two formats for turning in stuff in this class. One is the scanned PDF. The other one is this Word document. So, okay, so let me share this. Let me make this a little bit bigger. Give me a moment here. Okay, so let me share this. So what she would do is she took very careful pictures of her work and she scanned them in very, very nicely. And so you see this work here. This is very, very nicely done, in order. Very easy to read. Pictures are right side up, easy to read, actual size, and this is perfectly fine for me. If you don't have a scanner, all she did is she opened up an empty Word document and she took pictures and put them in a very nice order, placed them in this order. So again, that's option B. So two options. I mean, again, the one I greatly prefer is the scanned PDF, or you could do this empty Word document and putting in pictures. So again, those are the two ways. Please don't send me a bunch of pictures. I've had students who've given me like 10 attached photos. I don't want that. I can't deal with that. And I'm also going to send a document later on today to kind of tell you the nomenclature of how to label your documents as well. Okay, and I thought I did that, but I didn't get to that yet. So I'm gonna do that tonight, and I'll put that on Blackboard. And that tells you how I want you to name the documents. That way it's most easy for you to identify yourself with your document. Okay, the next thing I want to talk about really is going to be the syllabus. All right, and so again, so if the lesson plan is the map of this class, the syllabus is kind of like the constitution of the class, if you will. And so let me go into that now. So again, that's the not too exciting, but very important. So let me share my syllabus. So again, all I have left to do in this class tonight is to walk through the syllabus, and then I'm going to take attendance. And then after that, I'll open things up for questions, but that'll be pretty much all I have. So you should see my syllabus. Do you guys see my syllabus showing to you?
Yes, sir.
Yes.
Yes? All right, good. All right, so the syllabus starts off with some basic information, my name, the term, important dates to keep in mind. So this is my email. Let's see here. The last day to drop the class, July 21st. Now, this is a virtual class. This is an online class. This class is, even though I make it hybrid, in that I, it's basically asynchronous, but I have 5 meetings that I require of you. But in general, if you're to meet face to face, we have a strict attendance policy. If you miss 15% of the total classes, the labs count as a class, and so do the lectures. Miss 15% of the total number of classes, then I'm required by the department to drop you. That is how things normally work if we're meeting face to face. Given that there is an asynchronous nature to this semester, I do not have the ability to drop you. So some students, they think, well, I'll just stop going and the professor eventually will drop me. Well, that's not the case here. The only way to drop this class is for you to physically drop it yourself. Okay, so it is incumbent upon you. I hope none of you drop this class, but if you do, it's incumbent upon you to be the one who does it. I cannot drop you. Only you can drop you. Okay, so if you wake up on on July 22nd and you're still enrolled in this class, you're enrolled for the long haul. And whatever grade you've earned at that point, I mean, you're going to have to, you can't get a W anymore. You have to get a letter grade at that point. All right. So again, keep July 21st in mind. Office hours, essentially within this particular arrangement, especially in the summertime, I would say send me an email if you need extra help. Or there is a tutoring center as well. Probably the tutoring center is the best option. And then if that's not satisfactory to you, then I would suggest send me an email and say, hey, I need help with this or that. I mean, I'm pretty swamped in this class. I mean, this class is very, very quick, so it may not be. I may not be the best option for homework help. Your tutoring center would probably be your best option. But I say office hours are by appointment. Okay, moving along the syllabus. The book for this class. Let's talk about the books. Okay, so let me stop sharing for a moment. Now I want you to listen very carefully about this. All right, so for this class, the official book is Physics, 11th edition by Cutnell and Johnson. Hopefully you can see it. So again, 11th edition, Cutnell and Johnson. Okay. Physics, 11th edition, Cutnell and Johnson. The ISBN number for this book is where is it? Let's see here. Where do they have it?
In your YouTube video, it looked like you looked at the back of the book to look for the ISBN number.
Oh, all right, good. You want it? Oh, there it is. Thanks. I wouldn't find my way out of a 7-Eleven. All right. 978-1-119-39187-6. So again, one more time, 978-1-119-39187-6. That is the official book of this class. That is the book where all homework problems will be given out of this book. The chapters that I refer to are coming from this book. Now, as budding scientists, one of the things you oftentimes do is you read other books. Now, the initial book, when I first started teaching this class in 2017, was College Physics by OpenStax. They're out of Rice University. Now, as far as I'm concerned, this is a superior book, and I did a lot of work to work a lot of problems out, and so you'll see me in my YouTube videos that I work a lot of problems in OpenStax. OpenStax is not the official book of this class. There's always this confusion. The official book of this class is Cutnell and Johnson, not OpenStax. OpenStax is a reference. And so I reference it a lot because, it's really a good book. It's from Rice University. It's an excellent book. And quite frankly, another good thing about this book is, you're coming to TCC to try to save some money, ideally. And, well, Cutnell and Johnson is like $150. And I don't see any way of escaping that. OpenStax, actually, you can download it, a PDF file for free. So I do not know why. This was the book, when I first started teaching here, and somehow along the way it became Cutnell and Johnson. But again, I have made noises to the college that we ought to be using OpenStax again. Some people agree with me, but the official book in this class is Cutnell and Johnson. All right. So again, OpenStax is a book you can download for free. I'll actually send you an email with the PDF file. So, and again, use it for reference. But again, officially, it's Cutnell and Johnson. Now, let's also be very clear on where the problems are. So if you go in this book, let's say I look at chapter 1. Now, at the very end of chapter 1, the very first thing you're going to see is a concept summary. It'll say focus on concepts. You want to actually, your problems are going to start where it says problems. It'll say problems, and that's where you want to look, and that's where your problem, that's where the problems in the book will start. So I see some people, they get confused and they start working on, focus on concepts and that kind of stuff. And you'll see some, some basic problems there. No, you want to start off where the book, in the chapter where it actually says problems. People get confused on that. So that's why I make it a point that, this is where you want to, that's where the actual problems start. Some people will turn in focus on concept stuff. And I don't, again, please do not do that. Please actually work out the problems. Okay, that's the textbook for the class. Let me go back to sharing again. Okay, you should again see the syllabus. Now, as I read the syllabus, the first page or so is actually put in by the school. So your professor, any other class you may have, you probably have seen this, and this is put in for me. So some of it is kind of uncomfortable topics, but it's in my syllabus. That's my name on it, so I'm going to talk about it anyway. So again, we start off. Now this is a good topic here. This is the Student Accessibility Resources Office. Now, again, I want to point out, and again, this is I say this a few times in my syllabus. If you have a documented disability of any kind, whether it be physical, mental, psychiatric, vision, or any other kind of disability that could possibly affect your ability to perform in this class, I cannot do anything to help you unless you go to the SAR, Student Accessibility Resources Office, and get it documented. And there's official letterhead that dictates to me how it is that I need to treat you differently. Again, I treat everybody exactly the same, unless I'm told on this documented letterhead that this student needs to have these particular accommodations. Again, I without that without those orders, I can't do anything. Okay, I don't favor one student over another. I treat every student equally. All right. So again, if you have any kind of disability, you need to go to connect with the SAR office as quickly as you can. And again, this is not retroactive. You can't say, well, I didn't do well in exam 1 because of this. I mean, well, I can't do anything about that. It cannot be retroactive. It has if this applies to you, you need to take care of it right now. All right. Okay. Next thing on my syllabus is campus carry. Now, again, I'm not really a gun person, so I'll just talk about this and then we'll kind of move on. But Senate Bill 11 of Texas says that all colleges that receive state funding allow their students to carry a concealed licensed handgun. Now, me personally, I don't know why you'd want to do that, but again, that's not my business. If that is the case, again, there's a few things here that must be concealed. We had somebody a few years ago who carried an open carry, and they were quickly arrested by the TCC Police Department. Now, this doesn't so much apply to this semester per se, because we're meeting virtually. But again, this applies, henceforward. When we come back and meet in person. Again, this is a policy. This is a state law. So again, now if you are a person that wants to carry a licensed concealed handgun on campus, you must realize that you're taking on a lot of liabilities and responsibilities. There are many places on campus where you are not legally allowed to go with your concealed handgun, including the theater, performance halls, health services, testing services, counseling, physical education, child care facilities, and the police department. Again, so understand, this law, and understand, what you can and cannot do. All right. So I'm going to leave it at that. Course evaluation. You have the ability to evaluate me and this course. And so again, I definitely like to understand from the students, what do you like about this class? What I can do better? Or the materials in the class, or do you like the book? Do you not like the book? Or so on and so forth. So this is your opportunity to evaluate the course, and the course evaluations are between June 22nd and August 5th. All right, so that's you could literally just go to the syllabus, which again is located on the Blackboard, and click on that link. That takes you to the course evaluation. Okay, any questions so far? And this is kind of a fire hose. Okay, next one's a loaded topic here, a very big topic. It's called Title IX. Now, every person has a set of civil rights. Yeah, and you have the right to not be discriminated, and based on a lot of different characteristics of your person, your race, your gender, your national origin, your sexual orientation, your previous military service, and so on and so forth. There's a long line of categories where it is illegal to discriminate. Now, that is not Title IX. Title IX has to deal in a very simple way. If you could put the words, the adjective sexual or gender in front of it, Title IX very likely applies. Okay, Title IX is a protection against sexual harassment, sexual assault, stalking, dating, violence, so on and so forth, just like it says. Now, this law, actually, it's been around for a long time. So it's about as old as I am. It was put into place with, of all people, President Richard Nixon. So it's been around for a long time. But there's a particular special special I would say emphasis on it, starting in early, basically January of 2020, right before the pandemic. And so there was a major change as far as how Texas administers or enforces these Title IX laws. And I want to really talk about that. Your other professors haven't talked about this. I mean, again, this is something that you need to know. All right, and so Texas is above and beyond any other state in the country regarding the enforcement of Title IX laws. Now, you might wonder, we were briefed initially to this by our attorney here at the college. You might wonder why Texas of all states. Well, and I'm kind of a cynical person. I kind of thought, well, someone must have lost a lot of money, And turns out that is the case. That there was a very big problem that happened in Texas, which caused this law, and the problem was at Baylor University. Now, Baylor is an excellent school. They have a top-notch, excellent physics program. They clearly have an awesome basketball program, as you saw back in March. But they also have a very high-powered football program. And so you've seen in the past that there are people who do major wrongdoings in very large sports programs, and they seem to get away with it for a long time. You saw the Jerry Sandusky issue at Penn State. You saw the horrible situation with the Olympic gymnast, the female Olympic gymnast, with this Olympic doctor, Dr. Nasser, where many of our gymnasts, including gold medalists, were violated in terrible ways. And then you see what happened at Baylor. So Baylor University is a high-powered football program. There is a lot of money in football. In most universities, the highest-paid person on the payroll is the football coach. If you go to, for instance, TCU, where I got my PhD, TCU, the football coach makes about, last I checked, about $5.1 million per year. There's no professor in the country that makes that kind of money. So there's a huge amount of money in these football programs. So what happened at Baylor was there were some players that committed horrible offenses against women. And so this was brought to the attention of the president and chancellor of the university, a gentleman by the name of Kenneth Starr, and he claims that he didn't know anything about it. Now, if you haven't heard the name Kenneth Starr before, I'll kind of give you a little context. You remember our former president Trump. He was impeached not once but twice. But the first impeachment was, we had a special prosecutor by the name of Robert Mueller. Well, if you go back to the previous president who got impeached, it was Bill Clinton. And a special prosecutor for Bill Clinton was a person by the name of Kenneth Starr. Now, Kenneth Starr capitalized on his fame, and he ended up becoming not only the chancellor, but the president of Baylor University. So when all of this is going on, they asked Mr. Starr, didn't anybody tell you about this? How did you not know about this? And Kenneth Starr, said, oh, nobody told me. And so he later, not too long afterwards, resigned. But Texas essentially responded by saying, never again. This is never going to happen again. At any college or university in Texas, this is never going to happen again. And so this is what we're going to do. We're going to force any of our professors and our staff, if they ever hear about any kind of sexual violence or sexual harassment or any kind of violation of Title IX, they are required to report it. And those reports all go straight to the president of the college or university. Okay, so, and again, I'm a person who advocates for my students. If there's a student who's hurting and that person wants to talk to me, I want that student to realize that they can come to talk to me. And I will do something about this, right? But now I'm required to. So if you come to me, or even if I overhear what I think is a Title IX violation, I will report it. I'm required to. I'm forced to. There's nothing I can do about it. And so if you come up to me and say, hey, can you keep this a secret? If it has to deal with Title IX violations or anything, sexual harassment or sexual assault or anything like that, my answer is no can do. I must report it. I'm legally required to. And those reports go straight to the president, and they all get investigated. All right. And so this is the stance that Texas has taken. And this kind of thing that happened at Baylor is not going to happen again. At least we hope it doesn't. So again, that's what the main law, and it came into effect in January of 2020. And then of course the pandemic happens a couple of months later. And so we really are not meeting face to face. But again, these kind of sexual harassments and these kind of things, they don't have to necessarily happen in person. They can happen via email, so again, keep that in mind. If your other professors haven't talked about this is a very important piece of legislation. And so again, there's a lot of information here that is there to help you. So again, I am an advocate for the students. I am an agent for the students. So if something's going on, you need to talk, absolutely feel free to talk to me or any of the other professors if you feel more comfortable with them. Okay, next topic, pregnant and parenting students. Again, you cannot be discriminated via pregnancy. Again, that's another Title IX, that would be another Title IX violation. So students, you cannot discriminate students based on pregnancy, childbirth, anything like that. That, again, there are laws to protect that against that kind of discrimination. Okay, now we go into that. So that's what TCC put into my my syllabus. I guess before I move on, are there any questions about anything I've talked about up until now? Okay. This next section I talked about. I showed you what the textbook is. Again, the official textbook is Cutnell Johnson. Publishers Wiley. The actual authors are Dr. David Young, Dr. Shane Stadler. There is no laboratory manual in this class. Again, as I showed you, there are laboratory exercises that are on Blackboard. Materials in this class, generally you can get by with, a good scientific calculator. Again, don't buy something that, that's expensive. No, let me show you what my calculator looks like. All right. Again, I have a calculator that's pretty simple. It is a $15 calculator you get at Walmart. I got my PhD with this calculator. You don't have to, if you need to go, make fancy graphs, there's Excel or there's other software. Don't go and spend a bunch of money on a calculator. There's absolutely no need to do that. All right. $15 calculator at Walmart is good enough. All right. As long as it has, trigonometric functions, sine, cosine, tangent, natural log, logarithm, and it multiplies, adds, and subtracts and divides, it's perfectly good. You'll sometimes need a ruler or protractor, graph paper sometimes, particularly when you're doing the graphical analysis in the vectors lab. Most of the time, you're not going to need all that stuff. Most of the time, you're perfectly fine with paper, a calculator, a scientific calculator, and pencils. But like I say, every so often you need a protractor and graph paper, like particularly when you're doing the vectors lab. Okay, I talked about the prerequisites of this class, the math prerequisites. I talked about what this class is going to be about, problem solving, physics problems and learning physics. Now, the attendance, makeup, and late work, again, the work needs to be on time. So again, I hope I updated this, but all homework for a given week is due the Wednesday of the following week, and all labs for a given week is due the Friday of the following week. Again, there's only 5 times you have to be in attendance in this class, and that is tonight and the 4 exams. Do not turn in late work or incomplete work. I mean, I'm only one person, and this is particularly true when in the summertime, when I'm going to be like, a juggler with, 10 balls up in the air trying to juggle everything, because this class goes fast and it's just as hard on the professor as on the students. Believe me, there's a lot that goes into grading in the class, and I have to grade in batch. I can't grade onesie twosie. No, I grade everything. I grade everybody at the same time, and it works most effectively for me. Grading. I don't give a letter grade in this class until the very end. And so the class, basically, there's at the very end, I apply a weighting scheme. 50% of the grade in this class is based on your exam performance. There'll be 4 exams in this class. Now, there's always again, all the exams are 10 problems. Each problem is worth 10 points. It's 100, and there's 5 extra credits. So, and on any given exam, you can get 105. So I give it an extra credits or Mickey Mouse questions. There's fill in the blank. One word answers like who's the English scientist who came up with the laws of motion, blah, blah, blah. Isaac Newton. There's a point right there for you. So again, it's there's not even, generally speaking, it's not even a problem. It's more fill in the blank. If you listen to my lectures, and oftentimes I'll give you what the answers even are. I mean, in fact, I will conduct exam reviews. So again, in a given exam, so again, pay close attention here. Exams are always on Thursday. I will give an exam review the Tuesday of the prior week. Okay, so you go to the week before and go to that Tuesday. That's when I will give the exam review. Okay, so we'll meet in a Zoom session, and I'll go over a review, and I'll give you a review to prepare for the exams. And I try to do everything I can to get you so that you are as prepped for the exam as you can be. So again, but the exams are going to be in this class, they're going to be open notes. You can use Cutnell and Johnson. You can use OpenStax. You can use previous homework. Again, I ask you to kind of limit it to that. But again, you have the ability to to have stuff in front of you during the exam. I don't want other people near you. I don't want you on your cell phone or looking things up on your computer. Again, those are a pretty rich set of resources. There will be homeworks, and altogether there'll be an overall total, how many points you got out of the total number of points. That'll be 20% of the grade. And then your labs, each lab will be worth 100 points. And so that's a percentage. And then so that's 30% of your grade will be labs altogether. So 50% of the class is not even exams. So really, you work hard on the homeworks and the labs. 50% of the class, I mean, you can, if you're not an exam taker, 50% of the class is not even against. I mean, I have the lowest percentage of non-exam grades probably of anybody in the district. If you look at my overall grades, now I give you all kinds of opportunities. I'll give you an extra credit opportunity. I'll tell you about it in a few weeks. You'll have an extra credit opportunity. Likely, what I do is I replace the lab grades. So whatever your lowest lab score is, I'll replace it. You do this report, you'll get 100% on it. I'll give you 100% on it. That replaces your lowest lab score. So yeah, there's opportunities for extra credit. So at the very end, the only time I'm really draconian is when I look at where your final grade lies in accordance to that grading scheme. 88 is the lowest A in the district. So I mean, that's my low A, 88, not 90, 88. I have the lowest B at 78, lowest C at 68, so on and so forth. So I'm already cutting you a break there as well. All right, but if you get an 87 in the class, you got a B. I mean, don't tell me, oh, 87 is so close to an 88. Well, then if I say, okay, fine, 87 is an A. Well, if I do that, then somebody else, the next person else, can say, well, I got an 86.5. That's really close to 87. Could I, and then next thing you know, my grade, my A will just get walked on down. And I can't do that. I have to hold steady on something in this class. So the only thing I'm draconian about are where your final grade ends up on that scale. That's what your grade's going to be in the class. I mean, and at that point in time, I'll give you all kinds of opportunities to get a really good grade in the class. In general, I'm one of the, if you're to, look at my grade breakdown, I'm somebody who is probably the most generous of the entire district on grades. Generally speaking, historically, about half my students get A's and about half of them get B's. If you don't get a B in this class, then it means you probably didn't try very hard. Because you don't have to be, gifted in physics to get a B or an A in my class. I mean, you just have to work hard. And I do everything in my power to try to bring success your way. But again, there's work required from you. The class does require work. If you look at my rateyourprofessor.com, it'll say you will work hard in this class, and you will. But again, you have a path to success. More so maybe in this class, you might in other classes. Physics is an empirical study. Now, there are two types of physicists in the world: theoretical physicists and experimental physicists. All right, and so how physics works is, something becomes scientific fact when it gets published in a physics journal. And so, for instance, you might be an experimental physicist, and you might see something in a lab, you don't understand it. You'll study it, and you'll write a physics journal article. You'll put it into a physics journal, a peer-reviewed physics journal. Now, a theoretical physicist like myself might read that article, and I will try to explain it in terms of physics theories. And it may very well be that I have to actually add to the theory. Maybe the theory is insufficient, but I will publish a paper, and I'll say, well, this is what the theory states, and if this is correct, you might see this, and this as well. And another experimentalist might look at it, or maybe the same one, and that person and those people will do an experiment. And when you do an experiment, three things can happen. Either you corroborate what the prediction is, or you refute it, or most exciting of all, sometimes you get a surprise. And so again, and then that person, the experimentalist, will then do the experiment, report on that in the physics journal. A theoretical physicist will read it. And physics works like this until you converge to the truth. That's how science works. So again, labs in this class are extremely important because physics is empirical. So you see in dark bold here, you must pass the lab to pass the class. You can't, even you may ace all my exams and the homeworks, but you don't do the labs. And if your lab is a failing grade, irrespective of whatever you do in the rest of the class, you fail the class. You have to pass the lab to pass the class. All right, and why is that so important? Because physics is a laboratory science. Think that is all right. So again, I talk about, here we go. I talk about daily assignments. So again, the assignments are I've talked about all of this, and you can kind of reread it for yourself. But again, all labs are all homework. There's all homework, for a given week is due the Wednesday of the following week. All labs for a given week, the lab writers are due the Friday of the following week. Again, you will take your exams in front of the camera. I give my email address right here, mark.o'callahan0121@gmail.com. January 21st is my birthday, so I stepped that in there. So anyway, so mark.o'callahan0121@gmail.com. I set that website, that email up specifically to receive anything that is graded. All right, so that includes homeworks, labs, exams. Anything goes to that. Now, if you want to talk to me about something else, you can go to you can write me on my TCC emails, but please do not flood my email with homeworks. I mean, there's 24 of you. If I have, 4 things due in a given week, we're talking about, possibly 96 emails I might get. So again, it's, please don't flood my email. Now, I do want to point out something as well. Please turn in each chapter homework separately. All right, so so chapter 1 should be a document in and of itself. Chapter 2 should be a document in and of itself. Don't combine them together. So, again, chapter 1 homework, you might turn them into, so chapters 2 and 3 next week, right? They're due the same time, but please turn in 2 separate attachments, a chapter 2 document and a chapter 3 document. All right, don't just smush them into one. Each lab, again, is also separate. So you'll have the data analysis lab. Again, that's a separate lab. Uniform accelerated motion lab, so on and so forth. Each of the labs should be, again, their own separate documents. I'm going to put a naming scheme for your homework and lab files. I'm gonna do that tonight, and I'll put that on Blackboard, and I'll alert you. Another thing too, keep in mind is all of you should have an email that's, first name, last name, whatever it is, at my.tccd.edu. Again, make sure you can log into that email account, because I communicate extremely heavily on email. I'm a big time emailer. I mean, even if we're meeting face to face, you'd still get 3 or 4 emails a week from me. So again, that's my favorite way of communicating is email. So please make sure you check your email frequently. Okay, I send a lot of blanket emails. When I grade your homework, when I grade, for instance, what I'll do is I will grade your homework, and then I will send you again, put the grade on there. Let's say there's 10 points on the homework and you got 9 out of 10. I'll send you a separate email that tells you what problem you missed. What's your score? What problem did you miss? That way, because otherwise, if you had 9 out of 10, that doesn't mean anything to you unless you know what problem is. So again, that's why there's the extra work during this virtual learning, is that if we're meeting face to face, you turn your homework in, and I would just pick it up, stick it in a folder, get out a red pen, mark it up. You'd know what you missed. I'd put the solutions on Blackboard. I put your grade in. I don't have to actually read a bunch of emails, get on the computer, process stuff. I mean, it's a lot easier on me, and then you automatically do, okay, what problem did I miss? Oh, I missed number 3. What did I do? But now I got to tell you in a separate email that you missed number 3. right? And so again, you know, that's the extra work. So again, there's a lot of emails that I generate, and so please make sure that you know that you can log in and you can see your email. Again, I say work in pencil. Again, make sure that you check before you send me something. You check what it looks like. Can you read it? I seen people turning stuff, and I'm like, there's no way I can read it. How can you read it? So again, make sure that you yourself can read it. Write in pencil that's dark. I don't want pen because there's strike throughs and things like that. I mean, I've been doing physics since I was like 9 years old, and I still make mistakes. And I do all my work in pencil. So again, make sure it's a thick enough, it's a dark enough lead that you can actually read it easily. And I think that's about all. It's all I have. So, again, when you take your exam, don't use your cell phones. Don't phone a friend. Don't talk to other people. Again, this is now don't go away yet. I need to do attendance. So, but anyway, so before I do attendance, so I'll ask you, do you have any questions? So don't leave me yet. No questions. All right. Now I'm going to go through here and find out who's here. I may mispronounce your name. If I do, please correct me. And if you go by another name, please tell me that as well. I'm literally just going to read what's on my, what was on the, I just printed out what was on the TCC website. So, if I, so again, I can possibly mess your name up. So if I do, please correct me. I have Jacob Bichelle. And please turn on your camera so I can kind of know what you look like. Jacob Taylor Bichelle. Anybody? No. All right. Aaron Bajani.
Can you hear me?
Yes.
I'm Jacob. Sorry, I had the wrong microphone in effect.
Oh, okay. Do you go by Jacob?
I go by Taylor mostly.
Oh, Taylor. Okay. I'll make sure I call you Taylor. Awesome.
Okay.
Thank you. All right. Let's see here. Aaron Bajani. This print came out really small. All right, one more time. Aarin, Aaron Bajani. Okay. I know a few of you are missing, so I only have 19, including myself. So we have a few missing here. Samuel Brown. Anybody? Samuel Brown, please speak up. Samuel, or maybe Sam Brown. All right. Emily Dang.
Right here.
Very good. You related to anybody named Mary?
I'm sorry?
You related to anybody named Mary? I had a Mary Dang in my class one time. No?
No.
Okay, just curious. Cheyenne Dawson. Cheyenne Dawson. All right. Abelardo Esquivel Cabrera. Yes.
I'm here.
Can you speak up? I can see your picture.
I'm here.
Oh, there you are. Did I pronounce your name right at all, or do you go by
I go by Abel.
you go by what?
Abel.
ABLE or ABEL?
ABEL.
Okay, gotcha. Thank you. David Estrada Gonzalez.
Here?
Very good. Do you go by David or?
Yeah, David. Yeah.
Okay, very good. Thank you. Abigail Gapehart.
I'm here.
So you speak a little louder so I can see your picture.
I'm here.
Oh, there you are. So you go by Abby?
Yes.
Okay, Abby. Say hi to your brother for me.
Okay.
Elazar Garza.
Right here.
Is that pronounced
You
correctly?
did, yeah, you did good.
Oh, good. Awesome.
You can call me Zar though. I go by Zar, Z-A-R.
Zar? Just
Yeah.
Z-A-R? Okay,
Yes, sir.
awesome. Alrighty. Ashlyn Gibbs.
I'm here.
You speak a little bit louder, please, so I can see you.
I'm right here.
There you are. Oh, all right, very good. All right. You go by Ashlyn?
Yes, sir.
Okay, very good. Karen Hanna. I talked to you a minute ago.
Yeah, that's me.
You speak a little louder so I can see your picture.
That's me. Hi.
There you are. Awesome.
Is that better? Okay.
Yep, I see you. I just have to know what you look like so that when you take the exam, that's you again. John Hillman.
That's me.
Very good. Thank you. Soban Ho.
Hi, sorry, I'm driving.
Okay.
Hi.
Is Sovan, is that correct?
Yes, it's Soban.
Oh, very good. Thank you. Yvonne Huang.
Right here.
Did I pronounce that right at all?
Yeah.
Very good. Awesome. Raylon Huckabee. Raylon Huckabee. All right, not here. Caitlin Neblick.
Here, right here.
Hi, Caitlin. Titian Lay. First name Thuaytien, last name Le.
Oh, that's me.
Okay, did I pronounce that at all correct?
Yeah, you can. I can go by Lee.
Lee? Oh, okay.
Yeah.
Very good. Lee or Li or
Le.
Le?
Le.
Oh, is Lee your first name?
Yes.
Oh, okay.
Nguyen is first name. Lee
Oh,
is
and
my
when's your
last
first name? Oh, I'm so sorry. Do we? All right. But you go by Lee.
Yeah.
Awesome. All right. Samantha Marner. Samantha Marner. Yeah, I apologize. My this print is so small. Christine Morris.
Here.
Okay, you go by Christine.
Yes.
Very good. All right. DeAndre Rucker. DeAndre Rucker. All right. Priscilla Saavedra.
Here.
Did I pronounce that correctly?
Saavedra, yes.
So Priscilla, you go by Priscilla?
Yes.
Okay, very good. Thank you. Tiffany Tanaka. Tiffany Tanaka. Joan Torres.
Here, Professor.
Oh, very good. Thank you. And last but not least, Teen Tran. T-H-I-N-H, first name, Tran, T-R-A-N, last name. All right, that is all of you. So again, I've covered, I think, everything that I want to cover tonight. Been about, I guess, a couple hours now, so it's about right. So do you have any questions for me? Feel free to ask me anything. I fire hosed you, so.
I do have a question about like during exams. I know you said that we're going to be videoing you and we're going to be doing our exam and like have open note. When we scan our exam to send to you, mine is like an app on my phone. So should we let you know when we're going to scan our exam? So it
That's a
doesn't look
great,
like
that's a great question. Right. That's the only exception to the cell phone rule. Some people have their scanner as part of their cell phone. So all you do is during the exam, you just, when you're all pretty much all done, ready to collate your work, you just say, Professor, I'm gonna take my phone out to scan, and I'll say, oh, go ahead. So again, that's, so many people do their scanning via cell phone. That's a great question. I forgot
Do
to
you
say.
prefer if we say it, or do you want us to like put it in the chat so as to not disturb other people?
You can put it in the chat if you wish. Sometimes I don't see the chat, so I'm not so good at chat. I'm much better if you want to just say I'm going to take my cell phone. That's perfectly fine. You won't disturb people that badly.
Okay.
It's probably better to get my attention verbally, because I'll probably miss the chat. So.
Okay.
And then when you're done, like say you leave the session, once I receive your emailed exam, and again the exams will start at like 6:30. If you want to go all the way to like 11:30, I mean, if you're one of those people that need that amount of time, I mean, there's no time pressure. Take your time. I rather understand what you know as opposed to how fast you know it. So again, you'll have plenty of time to take the exam. I don't want that time pressure where you feel like you're sweating bullets to try to get everything done. I don't see any point in that.
Okay, thank you so much.
You betcha. Great question. I totally forgot to talk about that. Anything else? Again, this is questions are very important. So Richard Feynman was one of my heroes, and he's he would usually only teach graduate level classes like quantum electrodynamics, quantum chromodynamics, things like that, and he would meet his students every single time. First thing he would ask is, any questions? And usually students would have questions. And one time, they met and he asked that usual question, and none of the students said anything. And so his reply then was, why are you here? So my thing is, I am always open for questions. So if you have, so again, feel free. If you have any kind of question in your mind, I guarantee you somebody else probably has the same questions. Don't be shy. So any other questions?
Yeah, I have a question. So I take notes on an iPad. Do I need to print those notes out before I take the test, or can I just use the iPad?
Use the iPad.
Okay.
Perfectly. I had a student who actually did all of his work on the iPad, every single thing. He had a really beautiful purple handwriting and everything else he did on there. And if that's where you're comfortable, I want you to be in your comfort zone. If you're taking your exam, be in your comfort zone, be in this desk you like to work, in the environment you like to work. If you like to work on your iPad, do everything that makes you comfortable.
Okay, thank you.
You bet. Any other questions? Well, if you don't have any questions, then we can call tonight. So again, we're going to be very much asynchronous in this class. And so feel free to connect with me. I mean, the class is going to go quickly, but again, I've done everything pre-recorded so that you have as much freedom as you need. Now, there's going to be self-discipline required. there's a good and bad in everything. The good thing is, hey, I can do it, and I can do things whenever I want. Well, the whole point is, you have these videos and you have the homework, you got to kind of have to space things out, which is more comfortable for you, but you got to do it. You got to do it during the week. And if you need to get a hold of me, just basically send me emails, and then you and I can get together. Otherwise, the class is kind of more or less, it's an asynchronous kind of a method of dealing with things. And again, some people really like that, some people don't. So again, I want to make sure that you do what's most comfortable for you. But again, that people have all kinds of schedules. We're still coming out of the pandemic. People are still, we're there. The light at the end of the tunnel used to be way down there. Now it's pretty much right in front of you. We're coming out of the tunnel, but we're still, TCC is being cautious. When I see Costco actually have no masks, then I'll feel like we really are out of the tunnel. But so TCC is being a little extra cautious. But again, we're going back to normalcy in the fall. So anything else? All right, so if you want to drop off, feel free. I'll stay here until the last person's dropped off.
Bye, thank you.
Thank you.
Thank you, Professor.
Thank you.
Sorry, Professor. I had a quick question.
Sure.
It was just about the textbook. Okay, I was looking at two different books, and I really just want to know the difference. Is the ISNB like super important? Because I'm looking at one that's like, I think $300, and it's the Physics Volume 1 edition, and it's the Volume 1 edition 11, and it's for $77, and the other one is the same ISBN as the first one you gave, and that was the $300 one. That's what I'm asking. Like, is it the same thing, or does it have to be that specific ISBN number?
Well, it needs to be that ISBN number, because the problems. Now the unfortunate thing about this is the publishing company is just making a ton of money. Why you need to make 11 editions of the same book is, to me, it's like, do you really make that many mistakes, or are you just trying to fleece?
Yeah.
So you have to have the right book, but $300, that seems steep. Usually these books are right around 150. There's an option. There's a loose leaf option as well. For instance, you don't necessarily have to have the bound option. There's a loose leaf. These loose papers that come into a notebook. So those are usually like the cheapest, and those are perfectly fine.
Okay.
Don't spend $300. You should.
Yeah, because I think it's because it's the paperback version, but I was just asking because I just wanted to be entirely sure before I go ahead and order something.
Paperback should be cheaper, I would think. Maybe it's a hardback.
Yeah.
Don't
No, it says
don't.
paperback. Yeah, and I'm looking at it on Amazon, and while you were discussing the book, I was looking it up on Barnes and Noble, and I just couldn't find it for that specific ISBN. So I'll probably just go to the bookstore tomorrow.
Either that, or just there should be used books on Amazon. You should be able.
Yeah.
I don't even think this is the latest version. I believe there might be even a late. I think there's a little confusion about the version of the book, but this was. I hope the school doesn't change the version anytime soon, because I've already worked all the problems out, and every time they change the version, it's more work for the professor. But it's 11th edition, so I don't know if they made a new edition since. I'm sure they probably have.
Yeah.
Companies need to make more money.
Yeah, because even then the paperback version I'm looking at is used also.
Yeah,
so.
This book's been out for a couple of years, so it's get a used copy and make sure it's lightly used, or good condition. But don't blow $150 for this.
Yeah,
it's bad enough. It's too bad we're not doing open stats. You get it.
Yeah. All right. Well, that was my only question, Professor. Sorry about that.
No apology for questions.
Gotcha. All right. Well, you have a good afternoon, sir. Well, good evening, better said. Thank you.
You take care. Nice to meet you.
Hey, Mr. Callahan. I signed up for the wrong physics class.
You did? Okay.
Yeah, I just want to let you know. Hey, you seem really nice, and it's too bad you can't be my teacher.
Oh, thank you. What's your major?
I want to be a mechanical engineer, and I was transferred to Arkansas this spring.
Yep.
Or this fall, I mean.
You're my guy this semester. you're the person.
I sent you an email too, but I heard what you said in the first 20 minutes and I felt bad.
No, don't feel bad. I mean, that's why I say all that. Hopefully you can maybe pop into the University of Physics.
Well, I checked. It looks like TCC only has University of Physics 2 over the summer.
Oh, wow. Okay.
Yeah, I was bummed. I looked really hard because I don't know. I just didn't have it. I'll just take out Arkansas probably.
Okay. Well, I'm sorry to hear that.
Yeah, you're good. You have a good day, sir.
You too. Take care.